Oh, hi everyone. My name is Ben Lai, and I'm the engineer from Moldex3D. Today, our topic is advancing cooling design with conformal cooling. So let's just get started. Okay. So here's our outline. First of all, we will go to introduction of conformal cooling, about why we need to use conformal cooling and how we can product or manufacture the conformal cooling by several methods. Then we will go to CAE analysis using conformal cooling design. We will introduce our studio, the method to analyze the cooling analysis, and some tools provided to users help them to create a conformal cooling design easier. And the final one is case study. So let's go to the first section is introduction of conformal cooling. So in this chapter, we will cover up the cooling time injection molding cycle, common problems caused by cooling, advanced injection molding process, and conformal cooling insert manufacturing. So why we need to focusing on the cooling time? Because overall, our injection molding will separate into 4 main stages. The first one is filling stage, packing stage, then cooling stage, and the final one is ejections. And you can see this pie chart that our cooling stage is occupy over 60 to 70% of cycle time, which means if we can enhance our cooling stage efficiency, then we can cost down our cost very significantly. So we will start to the focusing on the cooling stage. And the other important things is why we need to stay focusing on cooling stage is after ejection, we will encounter some warpage issue, right? So because the polymer, when the melt is cools down from the high temperature to low temperature, it will shrink eventually. So if you can get the uniform temperature distribution within the mold, then your shrink would be more evenly. That might not cause the warpage, the deformations. So the temperature distribution is also mainly decided by your cooling channel design. So that's why today's topic will focusing on the cooling stage and about the conformal cooling design.